Bismillahirrahmanirrahim. Rabbish Rahli Sadri, Wayasili Amri, Wahlul Uqdatam min Lisani, Yafqahu Qawli. Assalamu alaikum. My name is Binash Mausam. I'll be reading Thomas Calculus, 12th edition. This book is standard textbook for first year undergraduate. I hope we have a wonderful time together. Chapter 1, Functions. Overview. Functions are fundamental to the study of calculus. In this chapter, we review what functions are and how they are pictured as graphs, how they are combined and transformed, and ways they can be classified. We review the trigonometric functions and we discuss misrepresentation that occur when using calculators and computers to obtain a function's graph. The real number system, Cartesian coordinates, straight lines, parabolas, and circles are reviewed in the appendices. We treat inverse, exponential, and logarithmic functions in Chapter 7. Section 1.1, Functions and their graphs. Functions are a tool for describing the real world in mathematical terms. A function can be represented by an equation, a graph, a numerical table, or a verbal description. We will use all four representations throughout this book. This section reviews these function ideas. Functions, domain, and range. The temperature at which water boils depends on the elevation above the sea level. The boiling point drops as you ascend. The interest paid on a cash investment depends on the length of the time the investment is held. The area of the circle depends on the radius of the circle. The distance an object travels at constant speed along a straight line path depends on the elapsed time. In each case, the value of one variable quantity, say y, depends on the value of another variable quantity which we might call x. We say that y is a function of x and write this symbolically as y equals f of x. In this notation, the symbol f represents a function. The letter x is the independent variable representing the input value of f, and y is the dependent variable or output value of f at x. Definition. A function f from a set D to a set y is a rule that assigns a unique single element f of x, element of y to each element x, element of D. The set D of all possible input values is called the domain of the function. The set of all values of f of x as x varies throughout D is called the range of the function. The range may not include every element in the set y. The domain and the range of a functions can be any set of objects, but often in calculus they are sets of real numbers interpreted as points of a coordinate line. In chapter 13 to 16, we will encounter functions for which the elements of the set are points in the coordinate plane or in space. Often a function is given by a formula that describes how to calculate the output value from the input variable. For instance, the equation A is equal to pi r square is a rule that calculates the area A of a circle from its radius r. So r interpreted as a length can only be positive in this formula. When we define a function y is equal to f of x with a formula and a domain is not stated explicitly or restricted by the context, the domain is assumed to be the largest set of the real x values for which the formula gives the real y values, the so-called natural domain. If we want to restrict the domain in some way, we must say so. The domain of y is equal to x square is the entire set of the real numbers. To restrict the domain of the function, to say positive value for x, we would write y is equal to x square for x greater than 0. Changing the domain to which we apply the formula usually changes the range as well. The range of y is equal to x square is 0 to infinity. The range of y is equal to x square, x is greater than or equal to 2 is set of all numbers obtained by squaring numbers greater than or equal to 2. In set notation, see appendix 1, the range is x square such that x is greater than or equal to 2 or y such that y is greater than or equal to 4 or 4 to infinity. When the range of a function is a set of real numbers, the function is said to be real valued. The domain and ranges of many real-valued functions of real variable are intervals or combination of intervals. The intervals may be open, closed, or half open, or may be finite or infinite. The range of function is not always easy to find. A function f is like a machine that produces an output value f of x in its range whenever we feed an input value x from its domain. Figure 1.1. A diagram showing a function as a kind of a machine. Input is x and output is f of x. The function key on a calculator gives an example of a function as a machine. For instance, the under root x key on a calculator gives an output value, the square root, whenever you enter a non-negative number x and press the under root x key. A function can also be pictured as arrow diagram, figure 1.2. In figure 1.2, a function from a set D to a set Y assigns a unique element of Y to each element in D. We can see that two different input values can give the same output value f of a, or it can happen that each element of x gives a unique output value f of x. Each arrow associates an element of domain D with a unique or single element in the set Y. In figure 1.2, the arrows indicate that f of a is associated with a, f of x is associated with x, and so on. Notice that the function can have the same value at two different input elements in the domain as occurs with f of a in figure 1.2. But each input element x is assigned a single output value f of x. Thank you for watching. Allah Hafiz.